Problem number 4. I have several expressions. I want to circle the ones that have the same answer as cosine pi over 6. Well, a few of them are easier to work out than others. In particular, part A, I know I can circle that right away because of the negative angle identity. The cosine of negative theta is equal to the cosine of theta because cosine is an even function. So I know that's the same. Look at letter E. What is pi over 3 divided by 2? Well, it's the same thing as pi over 3 times 1/2, but that's just pi over 6. So of course, letter E is the same. This is cosine of pi over 6. Letter D, I think I'll just have to work that one out and see if I get the same answer. I suppose I should figure out what cosine pi over 6 even is first. Cosine pi over 6, let's see, that would be 30 degrees. And so when I fill out my triangle, looks like the cosine ratio comes out to be square root of 3 over 2, adjacent over hypotenuse. What about sine of negative 4 pi over 3? Well, let's see, where is that? 4 pi over 3, 180 divided by 3 is 60 times 4 is 240. That's negative 240. So that would be go around to 180 and then 60 degrees more. So here's negative 240 degrees, or negative 4 pi over 3. That means this little angle here is 60 degrees, which means, of course, I have a 30, 60, 90 triangle. I'll fill in the sides appropriately. The 1 would get a negative here in the second quadrant. Well, sine ratio, opposite over hypotenuse, square root of 3 over 2. It's the same thing as cosine pi over 6. So that one is also equivalent. How about letter B? 5 pi over 12 minus 1 pi over 12 would be 4 pi over 12. 4 pi over 12 reduces to pi over 3. So I just need to figure out sine of pi over 3. That's 60 degrees. I could use this same picture. And obviously from this same picture, the opposite of the 60 is root 3, and the hypotenuse is 2. So once again, this is equal to root 3 over 2. This one is also equivalent. Okay, how about part C? I'm feeling like I should simplify the complex fraction in there, and I could do that with the LCD of all of the little fractions. 369, the smallest number that all of them go into would be 18. So if I come through here and multiply the top and bottom by 18, that should simplify things considerably. In the first multiplication on the top, 6 goes into 18 3 times, so I'm going to end up here with 3 pi. And then in the second multiplication, 9 goes into 18 twice, so I'll end up with 2 pi. And on the bottom, 3 goes into 18 6 times. So this comes out cosine 5 pi over 6. And now I'm wondering, is that the same thing as cosine of pi over 6? This is the only one I think I'm going to end up crossing out, and I can do it pretty fast because 5 pi over 6 is over here in the second quadrant, and I know that cosine is negative in the second quadrant, so of course I cannot possibly get the same answer. This one is not the same as cosine pi over 6. Number 5 is another trig equation to solve. This time we'll make use of u substitution. So I'll move that 1 over to the other side by subtracting 1 from each side. And then I'll make this substitution u equals 2x. I always want to get a trig function, a single letter, an equal sign, and a number. Now I want to find all of the solutions for u within one period. Of course, the negative 1 makes me think of the unit circle. I believe the only spot I could be at within one period would be right here. That's the only place on the unit circle that has an a coordinate of negative 1. And so u then obviously is pi. And then I want all of the answers, so I will tack on multiples of 2 pi. Now those are all the solutions for u, but u was something I made up, and so it's time now to replace the u with 2x and then solve that equation for x, which obviously I can do by dividing everybody by 2. And when I do that, I'll distribute that 2 on the right. I get pi over 2 plus the 2's cancel in that second part, k pi. In other words, pi over 2 is a solution plus any multiple of pi that you want to add or subtract on. Number 6, we will also use u substitution. I've got a couple more beginning steps to do here, so I'll subtract the 1 and I'll divide by the 2. That gives me sine 3x equals negative 1/2. I'll use u substitution to replace the 3x with the u. Now I'm in the format that I like. Within one period, I think I'm going to find two solutions here. Sine is negative in the third quadrant, as well as symmetrically over here in the fourth quadrant. My sine ratio is negative 1 over 2, opposite over hypotenuse. This is obviously a 30, 60, 90 triangle. Here's the little 30-degree reference angles. So one of my answers is this third quadrant angle, and one of my answers is this fourth quadrant angle. Well, let's see. The third quadrant angle would be 7 pi over 6. We know there's a 6 on the bottom because the reference angle is 30. And the fourth quadrant angle would be 11 pi over 6, 330 degrees. Of course, I'm going to be tacking on 2k pi here because I can circle around as many times as I want. If I were solving for u, I would be finished. But of course, u was something that we made up, and so then here at the end, we will substitute back the 3x. I'll need to divide everybody by 3. Since I have those fractions, it's probably easier to think of it as multiply everybody by 1/3. I'm going to end up with 2 lines of answers here. The first one comes from that first line. It'll be 7 pi over 18 when I distribute the 1/3 plus 2/3 k pi. 2 times 1/3 is 2/3. And then the other line will be 11 pi over 18 and also plus 2/3 k pi. Here are the final exact solutions to the equation. We found a couple of them, and then we're saying from those, if you add any multiple of 2 pi over 3, basically, you'll find other solutions.